In this episode, we're going to be looking at area. Objectives now. 1, we're going to define the term area. 2, calculate the area of shapes by counting square units. And 3, calculate the area of squares and rectangles using the formula. Now, what is area? The area of a figure measures the size of the region enclosed by the figure. This is usually expressed in terms of some square unit. Area can be described in everyday terms as the number of square units that can be fitted into a two-dimensional surface. It is measured in terms of square units, for example, centimeter square, meter square, square inches, square miles, etc. Area of a rectangle is equal to the width multiplied by the length. For example, what is the area of a rectangle having a length of 6 centimeters and a width of 2 centimeters? The area is the product of these two sides or lengths, which is 6 times 2, which would be 12, and the units now centimeters squared. Engage. Find the area of each shape by counting the square centimeters. So 1 square is equal to a centimeter square. So let's go for A. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Shape A is equal to 9 centimeters squared. The area of shape A is 9 centimeters squared. So for B, we have 1, 2, 3, 4, and 5. So B, 5 centimeters squared. Let's look at C. 1, 2, 3, 4, 5, 6, 7. So for C, shape C, 7 centimeters squared would be the area. Let's look at this one. A, I can see that we have 2 units here, and it goes down by 2 units as well. So if we were to multiply side by side, 2 times 2, we would get 4. And if we were to draw the lines here, 1, 2, 3, 4. B, we have a line that could go through here, dividing this into 2. And then one more line here, another here, another here. So we would end up with 1, 2, 3, 4, and then 1, 2. We could say 4 times 2, we should have 8. So let's look now. 1, 2, 3, 4 on this top part, and then 1, 2, 3, 4. So 4 and 4 would give us 8. So this should be 8 centimeters squared. All right, let's look at this one called D. This is 1, 2, 3, 4. So 1, 2, 3, 4. Yes. So this goes 4 units across. So this would be 4 centimeters squared. Let's look at E. This goes down 1, 2, 3, and it goes across 1, 2. So 3 2s would be 6. All right. So let's go 1, 2, 3, 4, 5, 6. So this would be 6 centimeters squared. Let's look at G. This is a big one, but we can figure it out. This goes across 1, 2, 3 units, and it goes up now 1, 2, 3, 4. 4 3s would be 12. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we took our pencil and traced the lines across, and then we were to count all of the little squares. So for the exploration here, they ask, how many rectangles can you draw with an area of 16 centimeters? All right, so let's see what we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that we have 10 here. All right. And if we have 10 there, then we have 1 2 3 4 5 6 7 8. So we have 8. So 8 by 10, this is 80. So we should have 80 centimeters squared in all. So one way of working this out is to say how many times can 16 go into 80. All right, so if we had 80 and we divide it by 16, then we and this is a fractional approach now, we could look and say both of these numbers are even, so 2 could go into both of them. So 2 could go into 80 40 times, and 2 could go into 16 8 times. And I know that 8 can go into itself one time and 8 can go into 45 times, but let's say we didn't know that. We could say 2 could go into 8 4 times, and 2 could go into 40 20 times, and 2 could go into 4 2 times, and 2 could go into 20 10 times. 2 could go into itself one time, and 2 could go into 10 5 times. Remember we had said 5 before, so we know that our answer here would be 5. So I'm supposed to be able to get how many of these? How many rectangles? 5. All right. Let's prove that in another way now. So the rectangles could be drawn 1 2 3 1 2 3 4 5 6 7 8 9 10. Could be drawn this way. Let's see if we can get it this way. 1 2 3 4 5 6 7 8. Yes, 8 to 16. So I could have one rectangle that looks like this. Let's go this way. And that's one rectangle. All right. So one rectangle with 16 centimeters square in there. Let's go 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. That's one. So we should be able to get how many more now? 4 more, because we have one already. So let's see if we can make this one nice and pretty. Let's go shade this one. All right. So this is the first one that we have. All right. So this is one. Let's see if we can. Okay, great. Let's see again. Looks like we could come here all the way down, all the way up. Good. And we have 2. Let's make this another color. Let's try this green highlight here. Good. All right. And then we go down and fill these in. All right, so we have 2. How many more should we be able to get? 3. So let's go now. So we should be able to get. So we have 3. Let's see. Now we have 4, and then we should. We have 5. All right. Let's see if we can get some more colors in here. First, we figured out how many 1 centimeter squares we had in all. So we know that we had 80 in all. And they asked us to see how many rectangles of area 16 centimeters we could get from this. So we divided the 80 by 16 and we ended up with 5. Explain what is the area of this shape if each square represents 4 centimeters. Explain how you got your answer. So how many of them make this up? Let's draw a line here and connect this. So I'd have 1 2 3 4 on the top side, and then at the bottom now I'd have 1 2 3 4 at the bottom. So I have 8 of them in all. So I'd need to multiply 8 times 4. Oh, 8 fours is 32. All right, let's go with this and see. So 4 and 4 is 8. 8 and 4 is 12. 12 and 4 is 16. That's the top part. 16 and 4 is 20. 20 and 4 is 24. 24 and 4 is 28. 28 and 4 is 32. Okay, that's how I would get it. Elaborate. Find the area of the shapes below using the measurements given. So for this rectangle, it is 6 times 3. This would be 18 centimeters squared. 5 nines would give us 45 centimeters squared. 8 twos, 16 centimeters squared. For this one, 7 eighths, this would be 56. So this is 56 centimeters squared. And if this is a square, that means all the sides are the same. So if this is 6, then the other side is 6 as well. So 6 times 6, 6 is 36. So this is 36 centimeters squared. Evaluate. The grade 4 students have a play area. These are its measures. 10 centimeters on this side and 20 centimeters on that side. 1. What is the area of the play area? So to find that, we'd have to multiply these two sides, the length by the width. So 20 times 10, that would give us 200 centimeters squared. 2. The girls say that the boys take up too much space with their ball games. They want to split the area into 2 equal parts. What is the area of each part? Area of each part would be 100, because 20 times 10, that gives the total area. So first we find the total area, and we work that out to be 200. So if we're going to give them half of that area, so we have equal parts, then the girls would have 100 units, and the boys would have 100 units as well. We have another question here that says that the students have a play area 20 by 10. So we could find the area by saying 20, and we'll multiply this by 10. Okay, and when we multiply this by 10, we would get 200. And then we have meter here, so it would be 200 meter squared. Now, they want us to say what half of this would be. So let's go. If I have 200 and I cut it in half, which means I divide it in 2, then I will have 100 meters squared for the boys, and then 100 meters for the girls. Now, I just want to point something out to you. Some people might say, if they were supposed to get half, then we could simply cut this in 2, the 20 in 2, and we have 10 here. Cut this in 2, and we will get 5 here. But 5 times 10 gives us 50 meters, which is a quarter of what we want. So how do we avoid making this mistake? Let's go back now. So what we would need to do, we could divide the play area in half like this. Okay, so that's one way of dividing the play area. Okay, so the boys would get this side and the girls would get this side, or vice versa. Or we could divide it like this. So instead we would have this total being 10 meters, and we could have 10 meters by 10 meters, and 10 by 10 would give us 100 meters squared. So please remember, guys, you can't divide both sides by 2,
because that's not how you would get 100 meters.
In this episode, we are looking at the concept of area, a very important concept in mathematics. Alright guys, take care, and I'll see you in the next episode.